Hello. Andy Palmer and myself are here to answer a question that we had from a user on the FlightCoach Facebook. I've only just joined this FlightCoach Facebook very recently, and I've heard a lot about it from Andy Palmer in the past. Just by way of introduction, you probably all know Andy, but my name's Andrew Tridgell, and I'm the systems lead for ArduPilot. I'm also the release manager for the fixed wing software that flies ArduPilot as a plane and works on the aerobatics support for ArduPilot flying aerobatics itself. So anyway, I've only just joined the FlightCoach group on Facebook recently, but I thought I'd take the opportunity, this question from Rune here, to help out a little bit for people in the FlightCoach community to understand a bit better how ArduPilot works underneath and how you end up with the sorts of problems that Rune has. All right, so Rune was basically, he had a flight log that he had where he ended up getting these sort of side steps, ups, down, and incorrect positions when he viewed the log. And so we'll just have a look at what his log looks like. And this is what his log looks like with the current FlightCoach plotter. So all I did was I just loaded up the log that he shared with me, which was this one. And I chose manual and brought it in. And you can see that he was obviously a very creative pilot with an incredible aircraft that's capable of doing little warps all over the flying field. So really, we all want an aircraft capable of doing this. But there is the possibility that he didn't do such creative flying and that there might have been a problem with the recording. So what I thought I'd have a look at is show you how to look at the log in a little bit more detail, and so you can tell a bit better about what's going on with these positions. And what we're going to do first is bring up this website called plot.ardupilot.org. So this website here, so plot.ardupilot.org, this is one of several different log viewers for the ArduPilot community. And it's similar to FlightCoach and the plotter for FlightCoach. It's a web-based one, so it's really easily accessible. So we can go and load that log from Rune. And my apologies if I'm pronouncing your name wrong, Rune. We'll just load up his log here in that plotter, and you'll see that it comes up with the same sort of crazy position, all right? So this is clearly something badly wrong, but it has a few more options for how you view these positions. So if we click on this little 3D button here, we can choose how we're going to view this in 3D. And in particular, the most important is this trajectory source here. So the trajectory source is basically which of the log messages in the ArduPilot log it uses to form the path. Because ArduPilot actually records lots and lots of data about the aircraft. So we could, for example, go to the raw GPS, and we can see that the raw GPS looks a lot more plausible, right? That seems like quite a likely path that the aircraft took. And there is, in fact, even there's a little tiny aircraft wandering about there. This plotter, from a point of view of sort of reviewing your aerobatic logs, this plotter really isn't nearly as good as the FlightCoach one. I'm just going to turn off my my notifications here. Do not disturb for a while because I keep getting notified about emails. So you can see that the raw GPS data here is actually not unreasonable. So it's quite likely that that raw GPS data actually was correct. And the failure was in ArduPilot's code for doing what's called state estimation, which is where it takes the GPS data and your IMU and barometer and compass and does all of those all of those pieces of data. Oh, we can see the little aircraft there. There you go. There's the aircraft flying around. I don't know if it'll be clear on this video, but it is actually flying along that path there. It's just that I've just put up the wingspan here. That's better. Now we've got the wingspan and we can actually see the aircraft here going through its maneuvers, right? You can even see it doing the roll and things there. But you notice that the attitude, it's jumping about in attitude quite badly, and now it's doing flying sideways in a rather improbable fashion. Let me push that wingspan up even further so you can see that. What I'm going to do is I'm going to change here to a different attitude source for the roll, pitch, and yaw, right? And what I'm going to, so if I do back, my guess is that with the secondary attitude source and with GPS data, this one will actually do quite well. And that looks quite plausible now, right? We're not getting those jumps in roll. We're not getting the thing flying with an improbable, side slip and that sort of thing. That looks really quite reasonable. Now, we can also change our trajectory source to being what's called AHR2. And you can see that AHR2, it's not as bad as the original source that FlightCoach chose, but it's not as good as the raw GPS. You can see it's still got some jumps and things here that are not very plausible. All right. So I wanted to show you this because this is an easy way of telling where the problem is, because the first reaction of some of the people on Facebook here was that you must have a GPS issue. And while it could have been a GPS issue, in this particular case, it wasn't. And in fact, the description of the problem made me think it was fairly unlikely to be a GPS issue. Okay, so let's go and have a look a bit and talk a bit about ArduPilot's state estimation, how it works, why don't we just use raw GPS all the time, that sort of thing. So what we can do is we can go and have a look. If we go back to the plot section here and plot.ardupilot.org, then we can go into what's called the presets. You can in fact plot any arbitrary expression, and there's thousands of pieces of data that ArduPilot record that you can plot. But there's some particular ones that are commonly used, and they're available here in this presets section. And let's go and look under EKF3. So ArduPilot uses a technique, the primary method for estimating the position and the attitude and the velocity of the aircraft is called an extended Kalman filter, which is a really good method of doing state estimation as long as your sensors are fairly well conditioned, so they're fairly well behaved. And so when one of the nice things about using an EKF, and so ArduPilot has, in current versions of ArduPilot, there are two types of EKF we use. We call EKF2 and EKF3. And I'm just going to go and have a look at this graph here called Position Innovation NE. NE stands for Northeast. What this is going to do, it's got our little plot of the flight down here, but at this top part, what we're seeing in the data, a position innovation is the difference between, or an innovation in general in an EKF is the difference between a sensor measurement and the prediction from the filter. So at any point in time, a Kalman filter is constantly predicting what it's expecting to happen next, right? So this happens on this particular aircraft at 50 hertz. So every 20 milliseconds, it's saying, I predict that we are going to be there with this attitude and that velocity. And it does that prediction by taking the previous state and propagating forward using the gyro data, the accelerometer data, and basically a little propagation forward for that 20 milliseconds to get the next predicted state. And so these numbers here, and this vertical scale, that's in meters. So this is showing the discrepancy between the predicted and the measured. The measured is what's coming in this case from the GPS, because the position innovation northeast, the primary sensor for that is your GPS position. So we see we're getting these horrible jumps in the predicted, in the innovation. So a horrible discrepancies between what the GPS gives and what the Kalman filter is predicting. And that is a sure sign of a very, very unhappy EKF. And that is why the plot looked horrible. That's why that Rune got this, right? Because of these innovations. In fact, these lines here are exactly analogous to these spikes here. Okay, now we can see what happened to the other state estimations in ArduPilot, right? Because this particular firmware had two different EKF types enabled, and it's got EKF2 and EKF3. So let's go and see how EKF2 was doing. If we have a look at the position innovation northeast, you'll notice that the vertical scale here is now 0 to 14 meters, whereas on the previous graph, it was 0 to 300 meters. And in fact, for most of the flight, if we have a look over this area of the flight here, just zooming in here, you can see during the actual main part of the flight, the biggest innovation we got was about 3 meters, right? In other words, the biggest discrepancy between what EKF2 was predicting and what actually happened was about 3 meters. And so that means the EKF is a lot happier. I still wouldn't call this great. I mean, when I'm reviewing somebody, when ArduPilot's actually flying an aircraft, I look for innovations under about 20 centimeters or so. And so this is not a good result, but it's not a disastrous result. So there is still some sensor problems, but they're much more acceptable. And now part of the issue here is that this is a very, very old ArduPilot firmware. So if we go and have a look at the this little ... allows you to bring up other pieces of the log, and we can look under the messages here, and we expand out those messages. And one of the messages we get is this, giving us the firmware version. So this is ArduPlane version 4.0.9. And that is ancient history in the ArduPilot world. And because ArduPilot moves very, very fast, there's a lot of developments happening very quickly. I think we average something like 10 changes a day going into ArduPilot, and we have stable releases every 6 months or so. So this is about 3 or 4 years old, and it's really getting quite ancient by ArduPilot standards. I would expect that if a newer version of ArduPilot was used, that the result would have been a lot better. So one thing that Rune should look at is updating the firmware. And the next critical thing in this little one is see it says the type of board it is. It's an Omnibus F4 Pro, right? And that's important because that if you want to go and update your firmware, that tells you what firmware you need. Okay, you need the firmware for the Omnibus F4 Pro, which you might know already because it might be written on the board, but otherwise, if it's some sort of black box and you don't know, then it might be good to know what firmware it is. All right, so first suggestion to Rune would be to update the firmware to a much newer version. And another suggestion is to use this this plot.ardupilot.org tool to review your logs. And you can have a look at the GPS path like this and see whether it's doing well. So you can tell whether you've got an EKF failure or whether you've got a failure with your actual GPS. It also allows you to switch between the primary and secondary positions with the AHR2 position and the other attitude, AHR2 attitude for your secondary attitude. And that will allow you to at least review things partially. Unfortunately, this viewer doesn't have the lovely ribbon that that is on FlightCoach, and with the attitude encoded as colorized. And it really is a beautiful user interface, what's been done for the plotter. So if I bring up a more reasonable log here, then, you know, here's one of Andy's flights. And you can see that much more reasonable. But you can see here, see this little part here, this little glitch, right? Like that, where it's jumping. That's almost certainly the same type of issue. And it's probably caused, it might be caused by exceeding the G limit of the GPS. The GPSs that most people are using with ArduPilot are called U-blocks GPSs, and they do have a 4G, which is approximately 40 meters per second. So 1G is 9.8 meters per second. 4G, 40 meters per second. If that was exceeded during this maneuver, then it might explain this jump. But we can go and have a look at Andy's log here with plot.ardupilot.org and see whether, in fact, there is an explanation for that. That gives us an example that isn't quite so extreme. So let's just go and have a look at that one. All right, and we should see, again, without the ribbon, it's harder to see, but you can see that little jump here, right? So up here, you see there's that little unlikely, and when you were flying that, Andy, did your plane just suddenly jump down like 10, 15 meters?
No, nothing off Star Wars happened as far as I was aware.
Oh, that's a shame. That would have been great. So let's see if so POS in this case is the primary position solution from ArduPilot, which that varies depending on your configuration. If we go to, say, the raw GPS, yeah, that looks more plausible, doesn't it? And we could also have a look at AHR2, like a secondary one, and that's also a little bit better. We can also choose whether your attitude comes from the primary or the secondary. So you can choose separately where the trajectory comes from and where the attitude comes from. It would be really nice at some point to be able to get these types of little drop downs in the FlightCoach plotter, because I think that would combine the best of both worlds with the lovely ribbon and all of the beautiful features that you've got here, with the ability to choose your data source, and it would allow you to make a lot more sense of the data. So all right, now we'll go in and have a look a bit at EK2, EK3, this one just briefly, just for another example. So let's go and have a look at the presets for Andy's log. And he doesn't have EKF2 here because his firmware was built with only EK3. And we'll show in a minute, Andy and I will just go and have a look at what's called the custom build server for ArduPilot that allows you to choose what different state estimators you have in ArduPilot. So let's go and have a look at these position innovations. I meant to do the northeast. The down is just the height. And we can see here, and I believe, I should say, by the way, when I'm demonstrating this plot.ardupilot.org isn't the tool I normally use, so I'm not very good with it. I've got my own tool that I've developed, which is called Mav Explorer, but I do know that plot.ardupilot.org is easier to use, so that's why I'm showing it. And we can see this spike in innovation here. If we go back to the 3D view and we switch it to the POS one, that's it, and we zoom in on this part where there was this high innovation spike. No, that's not. One of the things you notice is that this plot here is synchronized with the graph up here, right? So when I zoomed in, it's now only showing that part of the flight. So we can in fact now zoom through here and find the part of the flight where that funny spike occurred. There it is. So we're in the right section there now. Yeah, there it is. We're in the right ballpark, and we've just missed it, gone past it. There it is, and I'll zoom that in from the right and a little bit further. And yeah, so we're out now. We're doing just this maneuver here, and if we have a look at, there isn't actually a lot going on in the innovations, but let's have a look instead of the northeast innovation. I mean, this seemed to be mostly a incorrect height estimate. This is a jump in height principally. If we zoom that around, we can see that in northeast, there wasn't actually much of a jump. So let's go back to our plot and have a look at our position innovation down instead. And now Andy was probably set up to use the barometer for height. Aha, there we see the issue. See this spike here? What happened was the barometer started going off, and the vertical axis here is in meters. And we can see that the vertical axis started going off by up to 5 meters, and then it did this. That's called a reset. So what was happening was the barometer became inconsistent with the IMU data, and then the EKF has this concept of a timeout, where if it stops fusing the primary sensor for an axis, so in this case, the primary sensor for height is the barometer. If it stops using the barometer for more than it's about 7 or 8 seconds, then it will say, that's getting silly. I'm going to assume that we're no longer got a little barometer glitch, because the reason why it would stop using it is it thinks it's a glitch in the barometer, right? And so it was refusing to use it, but after a certain number of seconds, it does a reset. It says, okay, I'm going to accept that barometer now anyway, because it's now been inconsistent for a long period of time. The most likely thing is, in fact, that the barometer is right. So that's when it made that decision to do this reset, and that's what caused this little jump, right? So now there could be some reason why the barometer is becoming inconsistent. The most common thing with this type of aircraft is the airflow, where you get like either a Venturi effect or a ram air effect in the fuselage, where the airflow into the fuselage as you're flying, depending on your angle of attack, changes the pressure in the barometer and starts pushing it either higher or lower than expected. Either that or the IMU data was inconsistent. For example, some vibration or aliasing in IMU. And if we wanted to tell the difference between the two, what we would need to do is plot the GPS altitude versus the barometric altitude and see, in fact, whether the GPS altitude was consistent, baro altitude wasn't. But maybe that's enough for now, just to show you how you can get the general idea of having a look at what's going on with your data. I mean, sometimes we spend hours analyzing a single log. Do you think that's enough, Andy, for people to sort of understand the basics of looking at these logs?
Yeah, Tridge, I think those are really great explanation. Absolutely. Very useful.
So that gets them started. Now, one thing that we mentioned was about loading a new firmware. Now, Andy and I, just to get you tempted, have been working on a new feature for ArduPilot specifically for use with FlightCoach. And that feature is now available via this website, custom.ardupilot.org. So you go into this custom.ardupilot.org, and this is a custom firmware builder. So it's a tool that enables you to create a customized firmware for your ArduPilot supported flight controller. And so what we're going to do is demonstrate how Rune would go and get himself the latest firmware with the latest features going on his flight controller. So you go to custom.ardupilot.org and you go add a build. Now, what it's doing is it's going and working out what different flight controllers ArduPilot supports, which branch you want. Do you want the stable or latest? So first thing we need to do is say what vehicle type we want. And for aerobatics, what we want is a plane, right? You can use this for copters and helicopters and rovers and submarines and things as well. But for this particular group, plane is what we want. So then we want what branch. Now, if we want this feature that Andy and I have been developing, which is specifically made to make life easier for people using FlightCoach, then you want the latest, because we only merged the feature about an hour ago. And so it's not in our stable releases. And so now what we want is the particular board, you may remember from looking at those messages from Rune's log, was an Omnibus F4 Pro. So let's go down to Omnibus F4 Pro. There it is. So now we've got.
Could we just remind people where on on plot you'd find the board information?
Yes, of course. So let's go back here and let's look at your one, Andy. So let's look. So we'll click the little dot, dot, dot. And then within dot, 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 you can look at people's parameters and you can look at their RC input sticks, which is not relevant for, a logger, and messages. Now, the messages is the key one that you want, right? And we can see that Andy was running an Omnibus F4, and he was running a much more recent version of the firmware than Rune was running, because it was a firmware that I built for Andy last week. Which is the 4.5.0 dev. And this funny number here is what's called a git hash. That's the precise version which allows a developer such as myself or Randy to go and look and see exactly what code was running. So it's gives the precise git commit, it's called. So we can see that that Andy was using an Omnibus F4, whereas when we loaded, if I go and load Rune's one, if I go to plot.rdupilot.org with Rune's log, then if I open that one and there's Rune's log. Great. And if I go to the messages here on Rune's log, then we will see hopefully in a few seconds. Now, of course, it's not going to work for us. It should have. It might actually require that we have a plot up first. So let's go and do one of those presets, EK3, position innovation northeast, and then we'll see if we can get this to now bring up the messages. It did come up a minute ago when I brought it up the first time. So it might be something to do with me having, oh, there it is, finally come up. Great. So maybe we did have to do a plot first. As say, I don't use this plotter very often. It's a very nice interface, but I've got my own, which has got some other special features that I use. We can see that this particular one from Rune was the Omnibus F4 Pro. These numbers after that, that's the serial number of the flight controller. And so it's a unique identifier. So that number there's only one of those worldwide that has that number, which is Rune's flight controller. And that allows us to tell when we've got two logs that it is actually the same aircraft, or at least the same flight controller. All right, so let's go back to the custom build server. So we're choosing Omnibus F4 Pro, and we're choosing plain latest. And now we've got a whole battery of options here we can choose to get us a customized firmware that does just what we want for FlightCoach. And the most important one is black box logging, this one here, okay? What that does is, one of the annoying things with using a black box logger with FlightCoach is that it's logging all the time. So you end up with these enormous log files. And that's quite annoying. Of course, that only happens if you leave the plane turned on the ground for a while. But what we wanted to do was make it so that it would automatically start logging when you start the takeoff. So Andy and I added this black box logging feature where as soon as you get a GPS speed of more than 5 meters a second, logging starts, right? And then when your GPS speed drops below 5 meters a second for a period of, did we make it like 15 seconds, Andy? Something like that?
Yeah, 15 or 30,
so,
yeah.
Yeah, so when basically the GPS speed drops below that threshold for an extended period of time, then it stops logging. And that way you get logging just with the period where you're actually flying. And that's pretty handy because it means you end up with smaller logs. And it doesn't matter if the plane is powered on for a bit on the ground. You're not going to get a whole lot of time just sort of sitting there with no data that isn't useful. So that it's good to have that black box logging feature, but we can also go, and under AHRS, you'll notice it's defaulting to just the newer EKF3. But as we saw from Rune's log, it's sometimes good to have both EK2 and EK3 because if one of them goes bad, you can still have a look on plot.rgpilots.org and see the other one, right? So you can see an alternative position solution. So it's quite nice to have both on the vehicle. Now, because this is what's called a 1 megabyte board, it's only got 1 megabyte of flash. In order to have both EKFs, we have to disable some other features. Now, Rune didn't have an airspeed sensor, so we could choose individual airspeed sensors, but what we're going to do is just turn off all airspeed sensors. And he doesn't have a camera, or I presume he doesn't. He doesn't have an on-screen display, so we'll just turn that off. He doesn't have a geofence. He doesn't have a video transmitter. We can just turn off all of these other things. We don't need these I2C displays. We do need the GPS driver, the U-Blox GPS driver. We don't need gimbal support. We don't need the extra LEDs and notifies and buzzer and tunes support. And we don't need quad plane support. So we're going to disable all the, when I disable quad plane support, it asked me, do you want me to disable all the other dependent features? And so I'll disable all the dependent features. We don't need soaring. That's an automatic soaring feature where it'll do thermaling, automatic thermal finding. Very cool feature, but not what we're after. We don't need rangefinders or VTOL frames. And we don't need any RC input. And we don't need all of these extra RC telemetry protocols, CRSF, etc. Right, so that's great. So that gets us down to a much, much smaller build. So now what we do is to click this button down in the bottom right, generate build. And that will go and make a custom build just for this board for Rune. And so it has to, it's in a queue. We only do one at a time, but it is actually running. You see it says running there. And then in a few seconds, the build is going to start scrolling past here, and you can watch the wonders of the RGPilot build server doing a custom build, hopefully soon. There it goes. Okay, so now it's started the build. It's getting all the features set up, and it should now, it'll take it about like a minute and a half, something like that, to do this build. And at the end of that, we'll be able to download what's called an APJ file, which is an RGPilot JSON, which is the firmware. It's the file you use to load a firmware. And then we would load that onto the flight controller using Mission Planner. You can see that is, there's a little progress bar in the background there, 49%. And this, or you can see there's little progress numbers. It's like watching grass grow, isn't it, Andy?
It is. Tridge, once we have the firmware built, I wonder if we could look at which parameters are required to log, maybe to try and optimize the size of the log file as well.
Yes, very good idea. What I might do, actually, I wonder if I've even got an Omnibus F4 Pro here to load this firmware and demonstrate the whole thing. Otherwise, we could do it on your board, Andy, or I could pick another board out of my collection. Let me just see if I happen to have an Omnibus F4 Pro lying around in my collection. That is an Omnibus F4. I think this one might be compatible with it. Let's see, what have I got here? What I'll do is I'll do one that the Maytech F405 wing, right, which is another popular board for this type of thing. So there's a Maytech F405 wing, and what we'll do is we'll demonstrate how to set it up. Okay, so we've now done the build, right? So we can go and close that. and there's our build sitting there. And there's this little button here, Open Build Directory, right? So we click on that, and then that gives us all of the build products, and they're available in various formats. The particular one that you will use with Mission Planner is called arduplane.apj, like that, and there it is. So we could then load that. All right, but what I'm going to do is I'm going to go and I'll now do the Maytech F405 wing, and so I'll start that up and create a firmware. Oh, there it is, add a build, and I should have chosen this one in the first place so that so I'm going to choose plane and Maytech F405 wing. Now, let's see if I can find that alphabetical order, Maytech F405 wing, and we're going to quickly disable some of these features that we don't need. And we're going to make sure we actually we don't want deep stall or quad plane. We do want black box logging. We don't need rangefinders, VTOL frames, telemetries, RC, payload, MSP. Let's see, we'll turn off the geofencing, VTX, OSD, and we're going to turn on both EK2 and EK3. And that looks about right. Turn off all the rangefinders.
And maybe the camera as well.
Maybe the camera, we don't need that. And we don't need that, or any of those. And great. And we don't need optical flow sensors. We don't need RPM sensors. We can sort of go into all sorts of detail, getting rid of things that we don't need. Great. Okay, that should work. So let's go and start generating that build for the Maytech F405 wing. So meanwhile, I'm going to dig about for an appropriate cable to plug this in. And I'll also fire up. Now, I'm actually running Linux here, but I do have a Windows box, and I'll just hold my nose for a minute and fire up the Windows box so I can demonstrate things for users, because I think it's far more likely that the FlightCoach users are running Windows than they are running Linux. So let me fire that up. Now I need to find a USB cable, a micro USB cable. Most of my cables are USB-C, but I do have a micro USB cable hiding here somewhere that I used this morning. And
Rich, I think one thing worth pointing out to people on the custom build server is the board name. If the board starts with a lowercase letter as the first letter, they're listed after the boards with the uppercase first letter.
Yes, we really should fix that. We should change it to be sorted by case insensitive sort. But yes, it's a bit of a trap. You have to scroll down. It is a case sensitive sort that's done there. Okay, so I now have my Maytech 405 wing plugged in there. And what I'm going to do is I'm going to, it's almost finished building that. We've managed to procrastinate for long enough that build is going to be finished. Great. Okay, Maytech 405 wing, and I'm going to now click on the Open Build directory, and I'm going to download that arduplane.apj file. There it is. So I'm now going to fire up Mission Planner on Windows. Great. And I am now going to go, I need to transfer that firmware between my two computers because I downloaded it on my Linux box. The simplest thing I could do, when you do something on the custom build server, the builds that you do are actually available to other people as well, right? So this Maytech 405 wing is available to anyone who goes and looks there. So if I open the build directory there on my Windows box, then there it is, and I'll download it on my Windows box. Great. Okay, so I'm now going to load this new firmware. So it assumes you've got access to the USB port. So I've just plugged this board in here I've got this Maytech 405 wing. I just plugged it in on USB. And now I'm plugging it into my Windows box. And what I'm going to do is I'm going to connect to it like, well, I'm not going to connect to it. I'm going to set up and do the install firmware, actually. So I'm going to go and this is the install firmware screen. And I'm going to load a custom firmware, that little button there, load custom firmware. Great, and now I've got to go to my downloads, and there's the APJ file that we just downloaded. Okay, and it's saying that we have to unplug the board and then press OK, and then plug the board back in again, which I will now do. And so there it is, it's connecting, it's erasing the old firmware. Goodbye, old firmware. And then it's
So
putting
Trip,
the new firmware on.
That was a really good point for those that might be their first time updating a firmware on a board using Mission Planner. You do not use the connect button at the top right of the screen when you load the firmware.
That's right. You go to the install firmware and then you use this load custom firmware. And once you've got the new firmware on there, we can now use the connect and connect to our flight controller like this. Great, so we're now connected to that flight controller, okay? Now, I happened to do my last test flight at Eli Field in the US on a simulator, and that's why it's showing me there. I don't have a GPS attached, so we can just ignore that location. Okay, so what I'm gonna do is just show you some of the parameters that are important for FlightCoach. And so we go into this config screen here, and I'm gonna go into the full parameter list, right here, and there's a few little ones that are worthwhile. One is under this logging tree. It's within the log file section. Then there's this parameter log file disarm rot. What that does is it says that, in fact, if you click on it, there's actually a description here which can be a little bit hard to read. You hover the mouse over it to get the full description. When set, the current log file is closed when the vehicle is disarmed. So what that basically means is that this disarm rotation means that when it disarms and then it arms again, it'll create a new log, which means each of your FlightCoach flights will be a separate bin file you review separately, which is much more useful when you're out at the flying field and you're doing several flights. If you power cycle the aircraft, it's no problem. But you might not power cycle. You might decide just to sit on the ground and have your cup of tea for a second and then go again because you've got enough battery. In that case, you want to set this disarm rot so that it does create a new, and so we set that to 1 and we go right params. Great. Okay, there's a few other little things you might find useful. This one here you might find useful. This is the maximum rate logging rate. If you think your logs are just too big and you're getting annoyed by how big they are, you can set the maximum rate that any message uses. And say 20 hertz or so is absolutely ample. You might even set it down to 10 hertz or 5 hertz. Some log messages in RGPilot come out at a very high rate and it just makes the logs very big. And for the purposes of FlightCoach, really, you don't need it to be quite that high, and that'll make your logs considerably smaller. All right. Now, what else? If we look under the arming section, then this is the new parameter that Andy and I have added recently. Remember when in the build, we selected that magic option for plane, which is the this black box logging option, that one there, right? Black box logging. So that created this parameter, arming black box speed. And that sets the threshold in meters per second of how fast the aircraft has to be going in its GPS speed before it starts logging, right? It actually arms and logs. And so you might like to set that to a higher or lower threshold depending on your type of aircraft, but Andy and I thought 5 meters a second is reasonable. It means you lose the first couple of seconds when you're doing the rolling takeoff, but typically that doesn't matter for the aerobatics logging. But you can adjust that to another value if you want to. have it go, it only grabs it once you're up to a higher speed or less. What other options do you think, Andy? EK2 and EK3. Let's go and have a look under the different state estimators. So let's go and look under, you'll see under EK3, we have EK3 enable. So we are using the EKF3 estimator. Let's go and check whether the EK2 is enabled as well. So EK2 enable is 0. We want that set to 1 because we want 2 bites at the cherry, so that if we get a problem like Rune had, where you get a bad log because EKF3 fails, or the other way around, you get a bad log because you are using EK2 and EK2 fails, you get both. So you get 2 different estimates. So we're going to write that, okay? And we have to, all of the EK2 parameters aren't there. If we refresh the parameters, they would turn up, right? And so we would be able to have a look at those EK2. There's all the other EK2 parameters now, right? And there are some reasons for FlightCoach why we might adjust some of these parameters, but I think that's a more advanced video that we cover another day. We're probably already putting people to sleep with this first video. All right, so now the AHRS type.
Couple of parameters maybe Tridge to look at. Log disarmed and also arming required, because those are parameters people might have changed before loading this firmware.
Indeed, definitely worth a look. I'll just have a look at this AHRS EKF type. This one here says what your primary state estimator is. Now, this is set to EKF3, and the FlightCoach plotter does look at this parameter. I believe from my memory from having a peek at it, that it looks at this parameter to determine whether it plots the EK2 or EK3 result by default. So it'd be great if it had some sort of drop down to choose which one to plot, but I think this is your primary position estimate. And so if you keep having troubles with EK3, you might like to set that to 2, for example, for EKF2. Or if you don't like EK2 or EK3 at all, and you just want to use the raw GPS always, 0 means use what's called the DCM estimate, which is uses raw GPS for position and a more primitive roll pitch yaw estimator. But be warning that the 0 there is less robust to compass problems. So if you've got current flowing past your compass and you get a bad compass, it's not very robust to that at all. All right, so that's worth mentioning, changing that so we can write that value. Now, logging. A lot of the FlightCoach users, based on previous advice, would have gone and set log disarmed, right, like that to 1. If you've still got that, you want to set it back to 0 if you're using our new black box logging feature. And that's because otherwise it's going to be logging all the time. So you want that at 0. If you've got an older firmware which doesn't have the fancy new black box logging feature, then you would need that set to 1 to basically say log all the time. The other one that Andy mentioned is arming required under arming. And again, normally RGPilot needs an arming step, but as a black box logger, you really don't want to have to bother with arming the flight controller. That's important for when it's actually flying the aircraft, but not important for a logger. And you might have set that to 0 because you wanted it to be always armed and logging with previous ways of using FlightCoach, but you now want that to 1 because this black box speed automatically arms the vehicle when it reaches that 5 meters a second threshold, right? So you should now set arming require to 1, meaning it does require arming, because otherwise it will be armed all the time. It'll be logging all the time, which is not what we want. We want to only be logging when we're actually flying. All right. Does that cover that well enough, Andy?
Yep, I think so. Maybe the only other thing, actually, what is logged? So the log file bit mask.
Yes, okay. We could have a look at that. And the default for plane on this log bit mask is 6533, which basically means all of the different types of logging. You can hit this, it'll set bit mask and choose what you're logging. And generally you do want to log everything. I think the reason why people might have, like I noticed for Rune's one, he had a lot of these turned off, and that makes it a bit harder to analyze the log. A better technique, that was an appropriate technique for when we didn't have the log file rate max. But now we've got this log file rate max. That is a better way to reduce your log size. And it means that if you do pass a log along to me or Andy to have a detailed look at, we will have more information available and we're more likely to be able to analyze the log properly. So I'd suggest you leave the log bit mask or reset it back to the default of 65535, which is all of the logging enabled, and instead use, if you do want to reduce your log file size, just set this down to log file rate max down to 20 or 30 or something of that order, which will greatly reduce the size of your logs. All right. So I think that's probably enough for people to get started, and hopefully this wasn't too much information overload. We'll post that into the Facebook group, and hopefully that will be useful for some FlightCoach users. And then if you have questions, please ask back on the Facebook group again, and so we can just continue the discussion and, you know, add more features as needed to make ArduPilot the best possible logger for the FlightCoach community.
Thank you, Tridge. Awesome.
Okay, fantastic. Thanks very much, Andy. I will stop recording here. And where's my little recording?